Okay, so on one like this, especially one like this, the scale of your diagram is really important, okay? Because if you don't get it quite right, then again, that thing we talked about the other day, your math and your picture are going to tell you two different things, okay? And we want them to be in agreement. So we have this combine harvesting the field. It first moves 950 meters at 30 degrees north of west. Okay, so my reference direction is west. Okay, and it's 30 degrees north of that for 950 meters. Right, so that's my first vector. I've got the x's and y's labeled, I put the hypotenuse magnitude on there and the direction. Now the second part is that it's going to go 45 degrees south of east. Okay, so east is my reference. Okay, now if I'm looking at this triangle here, okay, and I'm just, kind of doing basic geometry. If this angle's 30, this angle's 90, this angle is 60. Agreed? Which means the angle between these two lines, the red line and the hypotenuse, is 30 degrees. That means my next line needs to go below this one. Agreed? Since it's 45 degrees south of east. Okay? That's part of getting that scale figured out, having to know that, have that little bit of kind of basic geometry knowledge or experience or what have you. Okay, so I'm going to go 45 degrees south, but it's a much shorter line. It's only 385 meters. Okay, so chances are, okay, it's not going to drop below where the other one started. And by chances are, I mean it's definitely not. Okay, here's how I can tell that. If I'm not sure, I just do the calculation to figure out what black y is. Okay. This line's only 385 meters long. Black y is 475, okay? So it's definitely only going to go to about there, okay? 385 meters. It's about, I drew it about half as long as the other one. That might even be a little bit long for that diagram. Okay, so now I'm going to draw its triangle. I have to get rid of the rest of this reference line because I don't need it. Okay. This angle here is 45 degrees. This is x, this is y, and that's 385 meters. So that means my resultant goes like this. Now this diagram is busy. Right? There was no way for me to avoid drawing over top of other lines. Okay? So it's kind of inconvenient. So what we sometimes tell people is if looking at this like wigs you out and you're just like, no, I can't handle it, it's too many lines, it's too busy. Okay? You can always do this. Well, except you want to take all of it. You can draw this as separate triangles. Okay? Just draw that first triangle. Okay? Oops, not in blue, I drew it in black. Okay, so draw that first triangle just by itself. And I'm still doing it wrong. And I need to drink the rest of that coffee. Okay, 950 meters. Okay, here's y, here's x. This angle was 30 degrees. And then just draw the other triangle completely separate of it. Okay, I'm still going to do all the same math. Okay, I just will have to build my blue triangle after. Okay, so I can still find out what x and y are here, what x and y are here, add the x's and add the y's, and then at that point I'll be able to build the blue triangle. So if looking at this diagram just makes it too hard for you, do it this way. Okay, the advantage of doing this, what we call the separate triangle method, is you never get a busy diagram. The disadvantage is you also never see the big picture. That is, you don't know what your resultant's triangle looks like until pretty much the very end of the question. Okay? The advantage of this method, the tail to head method, is that you can always tell your beginning, your end, and all the intermediate parts. Okay? But the disadvantage is, in some situations, like this one, it can get pretty crowded. Right? So it's totally up to you. The steps don't change. You're still doing all the same geometry, all the same trig, all of that stuff. All the steps are still the same. You just have a picture that looks different. You wouldn't lose marks if you drew them separately and then put them together at the end when you figured out, oh, okay, so blue x is this much and blue y is this much, and I just build it at the end. This is my displacement, this is theta, this is y, this is x, and I build it at the end. That's fine. Okay? I just won't know what it looks like until I have blue x and blue y calculated, and then I draw it. Up to you. All right, keep going on that. I'll give you a little bit more time to get the math done, and then I'll go through it as well. As I go over this one, I'm going to show you what both methods, the tail to head method and the separate triangle method, look like step by step. Because, I mean, most of the steps are the same. Really, there's only one change, and it's near the end. Okay, so the next step for both of these, because we've drawn the diagram or diagrams for both of these already. Okay, now it's just finding the x's and y's. Right. So the first thing we've got to find is black x and black y, because that was the first triangle we drew. Okay, so black x is the adjacent side to the 30-degree angle on the 950-meter long vector. So we're going to go cos of 30 times 950 meters. Cos of 30 times 950. All right, so we got 822, and I'm just going to write 0.72 okay, on the board here, but I'm going to keep all those decimals. 822.72. Meters, and that is west. Okay, I'm going to find y. Okay, y is going to be the sine of 30 degrees times 950, which should come out to 475 meters, and that is north. Okay. No, I didn't just do trading my head. I picked 30 degrees because the sine of 30 is 0.5. I can do that. Okay, so don't be impressed. All right, so now I've got the two sides for the black triangle. Now I've got to do the same thing for the red triangle, and it's no different. I'm doing the same thing over here for the separate triangle method. I still have to find x and y and x and y. Okay, so now I'm going to find red x and red y. Okay, red x is adjacent to the 45-degree angle. So cos of 45 times 385. Okay, 272.24. 272.24. Okay. I'm going to keep all my decimals. I know I'm rounding off here. Okay, meters, and that is east. Now, if I have basic knowledge of geometry, I can save myself the face palm moment that would come if I went sine of 45 times 385, because a 45-degree triangle has two sides that are the same, right? Because 45 splits 90 in two. Okay, so I can just save myself a bunch of time and just write that y equals 272.24 because it's a 45-degree triangle. Meters, and that's going to be south. All right, now I can find blue x and blue y because I've got all the x's and all the y's. So our next step is add the x's together and add the y's together. And it's the same next step for the separate triangle method. Okay, I still have to find my resultants x and y. The only difference is on this one, I know what they look like. On this one, I have no idea yet. Okay, I'm going to get these numbers, and then I'm going to build the triangle with them in the separate triangle method. In this method, I've already built the triangle. I'm just confirming its dimensions. Everybody kind of follow me there? Okay, so to find blue x and blue y, so blue x is going to be 822 meters west plus 272 meters east. That actually means I'm going to be subtracting, right? So 822.72 minus the 272.24. Okay, and I'm so glad I got my calculator working again because now I can do this. And I can cheat. It goes so much faster. Okay. All right. 550.488 is my resultants x. Meters, and that is west. Okay, so now at this point, if I was doing the separate triangle method, I could now draw the x component for my resultant's triangle. Okay, and then the next thing I've got to do is calculate blue y. Okay, so blue y, I've got 475 north and 272 south. So again, we're going to be subtracting there. 475 minus 272. Okay. 475 minus that one gives me 202.764 meters north. Okay, now I'm going to go up. If I'm doing the separate triangle method, now I can draw that triangle. And it was 202.764. All right, now I have my resultant's triangle. Okay, I already had that on the original diagram, but now I have it on the other one. Now again, all the steps are identical. That's the only step that's really different. Okay, I have to build that triangle once I've found x and y with separate triangle method. I already know what it is if I use the tail to head method. Either one is going to arrive at the same answer and will give you the same amount of marks. It's just whichever one appeals to your visual cortex better. Yeah? All right, so now that I've got those, now I need to calculate the magnitude of D and the direction of D. All right, so calculate the magnitude of D. Okay, that's just going to be a Pythagorean Theorem calculation, 202 squared plus 550 squared. Obviously, I'm going to have all the decimals in that when I do the real calculation here on my calculator. So square root of that one squared plus that one squared. All right, so my overall displacement is going to be 586.64 meters. Okay, and now I've got to find the direction. I got to find theta. Okay, it's the same for both. I mean, you can see those triangles worked out to about the same dimensions, right? Whether I drew it afterwards or whether I drew it inside. Okay. So theta is going to be 10 to the minus 1. For me, that's going to be 202 divided by 550, okay, because of the way I drew it. All right, so we're looking at a 20.2 degree angle. And that is going to be which direction? North of west. Okay, last thing I got to check, significant digits. I'm looking at 2 significant digits because both of my angles were only measured to 2 significant digits. So my final answer is going to wind up being 5.9 times 10 to the 2 meters at 20 degrees. Oh, yeah. Oh, sorry. We're not there yet. Right. They want the velocity. So one more step. I just calculated displacement. All that work was to get the top of V equals D over T. Okay. Now they told me in the question that this takes 540 seconds. So I'm going to take that 586 and divide it by 540 with all the decimals in it, okay, in order to get my velocity. Okay, so I'm looking at 2 significant digits, 1.1 meters per second at 20 degrees north of west, or I could also have 70 degrees west of north if I had drawn the triangle the other way. Okay. All right, everybody okay with that? That's about as long as they can get with 2 vectors. Okay? Once in a while, I throw you a curveball and I give you one that's got like 4 vectors. Okay? Make you practice. Okay? I wouldn't do it on a test because it would take too long. Okay? A question on a test that's got one that's horizontal and one that's angled tells me you know how to do it. without taking 2 hours for you to complete. So that's not a lot of use. The displacement was 586 point something. 586.64. And so that's why I divided 586 by 540. Yes. Okay, any other questions on that one? Okay. Now, I've got a couple of ones I want you to try here. These ones are really easy. They're out of the workbook. They're basically just adding very simple vectors. They start out collinear, and then they go to perpendicular, and then they get more towards what we've done the last few here. Okay, so I'm gonna have you practice a few of these. Okay, the answers are right here. Okay, these are the answers here, so you can check them as you go. Okay, this worksheet is in your worksheet booklet, and I'm gonna put it up on the board here. Okay, just so you can see kind of the rest of them. But we're gonna work on that for a bit, then I'll give you a break, and we'll kind of come back to it. Okay, so I'll just pull those up here. Okay, so they start actually at the bottom of page 7, right? So bottom of page 7 is where you'll find the question that I had on the board a minute ago. Okay, let's start out with that, super easy stuff, okay, and then we'll move to a bit more difficult as we go along. Okay, if any of those give us trouble, I'll do some of them on the board. So for C, okay, for 3C, we're gonna have the diagram looking like this. We've got 8 meters east. Okay, 8.0 meters east, and then we've got 6 meters at 35 degrees north of east. So my reference direction is east. I'm going to go 35 degrees north of that for 6 meters. There's X, there's Y, and my resultant. Okay. I could either draw the dotted line right over top of my other lines if I wanted to, or I can draw it up top. Okay. It doesn't make a lick of difference either way. I'm just going to draw it down here because it's kind of convenient to do that. To just kind of overlap the other triangle. So green X and green Y. That's my overall displacement. That's my angle. And that's what that diagram should look like. That was the unit exam question 2 years ago. All right, so for the rest of 3C, okay, this is how we're going to go. The x component of the 8 meter long vector is 8.0 meters east, and the y component of it is 0 because it doesn't go north or south. Okay, for the red triangle, okay, our x component is the is the adjacent side, 35 degrees, okay, times the hypotenuse to get us that. So we're using cos because it's adjacent. Okay, so cos of 35 times 6. Gives us 4.91 meters, and then the y component for that will be the opposite side, so we'll go sine of 35 times 6 to get that side. Okay, and we're looking at 3.44 for that one. Meters, and that's north. This one is east. Okay, so if I want to find green x, okay, green x is going to be 8.0 meters plus the 4.91 meters. Okay, so I'm looking at 12.91 meters east for green x. Green y is the only y component I have, 3.44 meters. Okay, and then all I have to do is do my Pythagorean Theorem. Okay, so 3.44 squared plus 12.91 squared, square rooted, and I will get 13.4 meters. And then to find my angle, okay, 10 to the minus 1 of 3.44 over 12.91, okay, will give me my 75 degrees east of north. Or 15 degrees north of east, which is actually the way we drew the triangle. Okay? All right, so we're going to be working on that a little bit here over the next few days, okay? And then we're going to move into graphing, which will be a bit more review from Science 10. If I can get everybody to mask up and grab a paper towel, get your desk cleaned off, I'll come around and put everything in. You know what, guys, it's on me. We're not ready, so I'll wipe down the rest. You guys can take off.
I just like writing stuff for distance, like contact. I see them as like adding like
Yeah, I think you got 3 out of 5. Okay. Yeah. Sure.
Why do you sometimes when you answer those using the 10 power
Oh, for significant digits. So if I can only have 2 significant digits, but my answer is like 5,000,
Right.
then I have to pull it back to 5.0 times 10 to the 3, which is 1,000. Right?
Why, how do we know if we're going to significant digits?
When you look at your givens, like so for this one here, okay, that number has 2 significant
I
digits.
see.
That number has 2, so you always just go with the lowest amount that you
Okay.
actually use to calculate something.
Thank you.
Yeah? Come on in.
Kuha ka na lang din. Kaantayin mo kayo ko. Ay, ano. Ay, wala ko narinig yun. Hi, Mr. Cutter.
Hey, how's it going?
Good, how about you?
Oh, trucking along. How's second semester going?
Good. It's a lot lighter than last.
Yeah, what have we got this semester?
Math, social, and a couple projects for Mrs. Niven's computer class.
Oh, well, that'll be good. And that's the last one. Then
Yep.
You're done.
Yep.
Nice. You excited?
I am. It's like, yes, I'm almost done high school. Should I know it?
Have you got next year figured out, or are you just kind of waiting to see what happens with the world?
I think I'm gonna go to Bow Valley for the January spot for the business degree.
Okay, that'll be good.
Yeah.
Cool.
Yeah, I want to open up a gluten-free bakery here in Okotoks.
Eh, when will we come?
Okay. Do the business and then you got the experience with the baking on top of it.
Yeah.
Awesome.
With cheese.
Be fun. Is that 2-year program?
Yeah, it is.
With cheese.
And how did physics go?
It went well. I passed with an 80.
That's And no diploma exam, also nice.
Yeah.
Let's
But like, I
go.
wish I could have gotten it a little bit higher, but
It's tough, right? I mean, you have to do, what, 4 weeks online, so.
yeah.
Yeah.
Yeah, my big thing was that I kept mixing up the hand signs.
Oh, yes, yeah.
It's
Magnetic
like-
fields, yeah.
Current, field, current. It's
I
like,
know, I've always had
Ano,
trouble with
online na ako,
handles.
mamaya.
It's ridiculous, like,
Wala akong pagkain.
it's crazy.